This video is for lesson 4, solving multi-step equations, like we did in class today, except now we're going to check your review in a few. For those of you that are absent, I'm going to quickly show the screens that go with the notes so you can fill in the blanks. Read over it carefully and let me know if you have any questions when you return to class. So we looked at that we've already been solving two-step equations, and some were actually multi-step already. We looked at these to decide which one's multi-step and which one's two-step. This is a multi-step. You have to use the distributive property. That's step 1. Then you have to subtract. That's step 2. Then you have to divide. That's step 3. The second one is also multi-step. Again, distributive property. Step 1. This should be dividing by 5. Step 2. Then you add 6. Step 3, in order to get your solution, your answer down here at the bottom. The last one here is simply a two-step. Add 8 on both sides, divide by 4, and you make it to your answer. So we're going to be focusing on equations more like the first two, where it requires more than just 2 steps to get the solution. So here's a quick shot of the notes we took in class. So pause your screen, copy anything that you need. I'm going to scroll up, pause your screen, copy anything that you need. Then we'll move on to the next page. These were the examples that we worked through by combining the like terms. Once those like terms are combined, you have a regular two-step equation that you're used to doing. If you need to copy these examples, please pause and do so now. Here is this next page of notes and the examples we did by moving the variables to one side or the other. On number 4, you could either move the negative 8c or the 3c. I chose to move the negative 8c, but there's no reason why you couldn't subtract 3c on both sides. And then finally, the word problem that we did in class. So this now brings us to your review in a few. If you need to get these notes, please pause the screen and copy them. Now you'll remember that the only way this is effective is if you have tried these 4 problems and now you're just checking your work to see where you went wrong. I hope you notice in both number 1 and number 2 that we have like terms on the same side of the equation. Number 1, we've got 2y and we've got a plus y. And in number 2, we've got a negative 5c and another negative 5c. Those need to be combined first. So if you haven't started, start there. Come back to check your work. So we start with 2y, combining it with plus y. You'll remember that that has an invisible coefficient of 1. So 2 plus 1 makes 3. Our two-step equation, our equation gets simplified now down to 3y minus 7 equals 8. We're back to our couple here of 3y and our nosy friend of subtract 7. You undo the subtraction first. You undo the nosy friend using the inverse. The inverse of negative 7 is positive 7. So you're going to add 7 to both sides. The negative 7 and the positive 7 give us a value of 0. It disappears. And we're left with 3y equals 15. Now to split up the couple, to isolate the variable y, we have to use the inverse operation. 3y next to each other means multiply. The inverse of multiply is to divide. So we divide by 3 on both sides. 3 over 3 gives a value of 1. So we've got 1y, or y equals 5. For number 2, we've got like terms that have to be combined. This may be where you want your calculator, but it's negative 5 minus 5, just like it looks inside these circles. When you do that, you'll get negative 10. So I've got negative 10c minus 12 equals 8. adding 12 to both sides. We get the 0 here. Now we're left with negative 10c. Oh, hello. That was fun. Negative 10c equals 20. To undo the multiplication, you would divide by negative 10 on both sides, and you can't see it now. Oh, gosh, that's not right either. So 2 equals, negative 2 equals c, right? So here's your secret for now. Making these zeros, we're going to call math magic. You are doing math magic because poof, and the 7s and the 12 are gone. So somewhere on your paper, jot down you're doing math magic by creating zeros because poof, those numbers, those constants disappear. All right, on to the next two. The next two are examples of, would you stop that? Having variables on both sides. You can see that we've got 3n on the right and 5n on the left, negative 2n on the right, and 7n on the left. We need to get them all on the same side of the equation. And I want you to think about which way you want to move it for just a second. If I move the 5n over to the right, I'm going to be left with 0 over here. You can do that, and it's possible to work with that, but it may not be the best way to go. It might be better, save you some work, to move the 3n to the left over with the 5n. Now think about number 4. You could move the 7n over with the negative 2n. To do that, you'd have a bunch of negatives. If you want to do that, that's fine. But stop and think. What if you move it the other way? What if you take the negative 2n over to the left? Well, the inverse of negative 2 is positive 2. And most of us like to add more than we like to subtract. That's the way I'm going to work these. You can do them the other way if you like. You should still get the same answer, but your steps may be a little bit different. So if you haven't already worked these, please pause your screen, work them, and come back and check. In number 3, we'd already identified that we need to get all the variables to one side. I chose to subtract 3n on both sides. We made that math magic. 3n minus 3n is 0, so now we don't have the variable on the right anymore. And 2n equals 26 once we bring our work on down under that long line. Now to split up the couple, we use the inverse, which is to divide by 2, so n equals 13. The last one we have to do tonight is number 4. And again, we've got variables on both sides of the equal sign. We need to get them all to one side or the other. In my mind, it's easier to take the negative 2n and move it to the left, or at least to get rid of it on the right. To do that, we'd use the opposite of negative 2n, which is positive 2n. On the right, we make a 0. On the left, we add 7n and 2n. Now I've got 19 plus 9n equals 37. Sorry, the work in my next steps kind of in red's kind of messing this up a little bit. Now we want to isolate that variable. We want to get rid of that nosy friend. We want to get rid of that positive 19. The opposite of positive 19 is a negative 19. That causes us to do this math magic and make a 0. And now the 19 disappears on the left. We've got 9n on the left, and 37 minus 19 is 18. The inverse of 9 times n is to divide by 9, and n would then equal 2. So you've gotten your first taste of multi-step equations today, and tomorrow we will practice it a little bit more. If you want to practice some on your own, you can look on IXL.com. I think I had to find it in the 8th grade stuff. So we will work on this Thursday in class and again Friday in class. Then when you get back on Tuesday, we will review for your test over two-step equations, multi-step equations, translating words into mathematical symbols, and you'll take your test over the whole unit next Wednesday. So if you need to come study, come study. If you need to retake that first quiz, come retake that first quiz. We need to get those done. And hopefully this is getting easier, but we've got a couple more days to work on it. See you tomorrow.